Hey math kids, today we'll talk about geometric operations with vectors. And so we're given vector A looks like this, vector B looks like this, and they want us to show A plus B. So what you're going to do is just draw A first, and then you're going to take B and you'll start it where A ends, and that represents B, and then the vector from the beginning to the end of those, like the shortest path, is going to be vector A plus vector B. Alright, now the next one, we have a diagram that looks like this. A, B, C, D, E. And they want us to find BC plus CA. So we go BC and then CA. And so the result is going to be B to A. And so we would get BA. Alright, the next one is BA, AE, EC. So we go BA, AE, EC, and so the shortest thing is just from here to here, which is going to be CB. Oh, whoops, I did that backwards. We start from the beginning, go to the end, and so that is BC. Alright, let's try another one. So AB, BC, CA. So A to B, B to C, C to A. And since we started and ended in the same spot, that's just the zero vector. Okay, so nothing is really there. Okay, now the last part of this one is AB, BC, CD, DE. Okay, so A to B, B to C, C to D, D to E. And so if we start at the beginning, go to the end, that's just AE. Okay. Now we're going to be given a vector R, a vector S, and a vector T. They want us to find R minus S and draw it. So what's going to happen is we take R, it's positive, so we draw it in the same direction. But S is negative, so we're going to take S, do the same slope, but we'll end it like that. We go from the beginning to the end, and that represents that vector. Okay, the next one they want us to find is S minus T minus R. So S is positive, so we start with positive S. T is negative, and so we need to go, so this one's S, this is T, negative T. And then R is like this, messed that up. Hold on. Let me try that again. Okay, so I draw S, and then T is normally pointing kind of to the left, and so we'll make it point, not the same slope, point like that. So this is our negative T vector, this is our S vector, and then R, but it's negative, it's going to point this way, and so the resulting vector is from the beginning to the end, and that's going to be this. Alright, next one. We have points A, B, C, and D, and we want to simplify. So AB minus CB. Now, you may have noticed a shortcut on 2 problems ago. If we have AB plus BC, something like that, if these two are the same, they kind of cancel, and that would just be AC. Okay, so we're going to use that thinking. Now, we can't directly cancel anything yet, but if we switch the direction, we could rewrite this as plus BC, and so that's going to cancel those middles, and so the answer to this one is going to be AC. Now the next one they want us to do, AC minus BC minus DB. Let's see if we can cancel it. So AC is fine. Switch this one to CB. Switch this one to BD and change it to positive. These cancel, so the answer is AD. Alright, construct vector equations for the following. So R, S, T, and then we also have D, G, F, E. Okay. You just need to pick a point, go to another area, and see what happens. So I'm going to write down R, then I'm going to go to S, so I'm going to add S, and then the beginning of this to the ending of this is T, so we're going to get an equation that looks like that. This one, I'm going to start here, I'm going to follow D, and then I'm going to follow E, then I'm going to go backwards on F, so that's negative, and then if I go from the beginning to the end, that's G, so that's just 1. Now, depending on which direction you go, you could get something different, but you should be able to do algebra on whatever you got, and it will end up being the same thing as this one. Okay, now it says find in terms of R, S, and T. So we need to find RS, we need to find SR, we need to find ST, and we're given this diagram. So R, S, T, origin. This one is defined as R. This one is defined as S. This one's defined as T. Okay, so RS, we're looking at this. So we want something that starts here and ends here. So we're going to start here. We're going to go this direction, which is negative R. And then we're going to follow S plus S. And that's it. If you want to write it a little bit nicer, you can write it like that. That's what we got there. Okay, so SR. So we're looking for the same thing, but just backwards. So we're going to start at the beginning, go backwards on S, forward on R, and that's our answer. Once again, we could write it as R minus S if you like that way a little bit better. There we go. All right, now ST. So start at S, go to T. I need to write in these vectors a little bit more. So the red one and the red one. Okay. So we start at the beginning. We go backwards on S. We go forwards on T. And that's our vector. So we could rewrite it as T minus S. Okay, now we're going to talk about scalar multiplication. So if we have 2R plus S, or if we have R minus 3S, what does this mean? Well, if we're given R is this, and we're given that S is this, if we're trying to draw what's going on, we draw R twice, and then we draw an S. And so the vector from here to here would be this. Okay, if we do this, if we start with 1R, and then S normally goes in this, it goes kind of in a down and to the right direction, but this is negative, and we need to do 3 of them. This is our R, this is negative S, negative S, negative S. So the answer, we go from the beginning to the end, and that's going to represent that vector. Okay, this is sketch vectors P and Q if P is equal to 3Q. And then also if P is equal to negative 1/2 Q. Okay, so if we take Q and we multiply it 3 times, it will equal P. So, and Q could be like anything, but let's say Q looks like this. If we do Q 3 times, and then we draw a vector that long in the same direction, that could also be called P. Okay? Now over here, if P looks like this, or no, not that. Okay, so if we start with Q, and then we first flip it around because of the negative sign, so this would be negative Q. And then if we cut that in half, so imagine that's the midpoint, and then we draw a vector that just goes to that midpoint in that same direction, that would be P. Okay, once again, this is half as long as this. If you have additional questions, please come to Math Lab. Until then, calculate.